The Basics and Uses of Hydrogen by Sean O'Connell and Cassandra Dos Santos. The Basics of Hydrogen. The element of hydrogen was discovered in 1776 by Henry Cavendish. Its atomic number is 1. Its atomic weight is 1.00794. It has a melting point of 13.81 Kelvin, or negative 259.43 Celsius, or negative 434.81 Fahrenheit. It has a boiling point of 20.28 Kelvin, or negative 252 Celsius, or negative 423.17 Fahrenheit. On the left, we have hydrogen as appears in the periodic table of elements. On the right, we have what a hydrogen atom looks like, with 1 proton and 1 electron. Hydrogen is the simplest element. Its phase at room temperature is a gas. Its elemental classification is a nonmetal. Every hydrogen atom has only 1 proton. It is the most abundant gas in the universe. The Sun and other stars like it are comprised of hydrogen. Hydrogen is a natural element on Earth, commonly found as either a liquid, gas, or solid. It can be found in natural gases, coal, and petroleum. Hydrogen is an energy carrier, meaning it allows the transport of energy from one place to another. It takes more energy to provide hydrogen than the hydrogen provides when it is converted to useful energy. Hydrogen is believed to have been created during the Big Bang. Every second of every day, 4.5 billion tons of fast-moving hydrogen nuclei are turned into energy as they slam together to make helium within the 15 million degree core of the Sun. Hydrogen's basic uses. Hydrogen has the potential to have a greater use as a fuel in the future. Hydrogen-powered fuel cells are seen as the next pollution-free source of energy. It is also used in the chemical industry to make ammonia for agricultural fertilizer. Uses as a fertilizer. Hydrogen is a key component of ammonia, which is the key ingredient in most fertilizers. Almost all commercial-grade ammonia is produced by combining hydrogen and nitrogen at high temperatures with the help of a catalyst, also known as the Haber process. The molecular formula for ammonia is NH3. Here we have an ammonia molecule with 3 hydrogen atoms bonded with 1 nitrogen atom. Hydrogen's uses as a fuel source. Here we have the Space Shuttle Discovery, launched in 2011, the last shuttle to be sent to the International Space Station.
Start, 2, 1, boost ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
Seen in this view, the large brown cylindrical figure attached to the shuttle is the large external fuel tank, which holds liquid hydrogen and oxygen as its fuel source.
Discovery's 3 nuclear fuel engines now throttled back to 67% of rated performance, reducing the stress on the shuttles and brakes to the sound area. Discovery already rated at miles in altitude.
Liquid hydrogen is used as rocket fuel, where liquid hydrogen and oxygen are held in the shuttle's large external fuel tank. The plan for utilizing hydrogen as a fuel source is by using its abundance in our environment, such as being stored in water, H2O, and hydrocarbons such as methane, CH4. One of the challenges holding us back from using hydrogen as a fuel source is being able to efficiently extract it from its compounds. Currently, steam reforming, which combines high-temperature steam with a natural gas to extract hydrogen, accounts for the majority of the hydrogen produced in the United States. Using hydrogen as a fuel would mean emissions would only comprise of water vapor and warm air as exhaust. Because of the Energy Policy Act of 1992, hydrogen is considered an alternative fuel. Hydrogen fuel has the ability to power fuel cells coupled with an electric motor 2 or 3 times more efficiently than an internal combustion engine running on gasoline. Teslas. The car company Tesla uses fuel cells, the same ones that are found in our smartphones today, except the battery pack on the bottoms of Teslas hold not just one like our phones, but hundreds of fuel cells, all powered by hydrogen. This makes Teslas one of the first hydrogen-powered vehicles in our generation. Hydrogen fuel cells produce electricity by combining hydrogen and oxygen atoms, which results in an electrical current. There are different sizes and types of fuel cells and can be used for different purposes. Small fuel cells can power things such as laptops, cell phones, and military applications. Large fuel cells provide electricity for emergency power in buildings and in remote areas that are not connected to power grids. Most current hydrogen-fueled vehicles are automobiles and transit buses that have an electric motor powered by a fuel cell. The high cost of fuel cells and the limited availability of hydrogen fueling stations have limited the number of hydrogen-fueled vehicles.